Hi students, in this video we're going to look at residual plots and use them to analyze and evaluate the effective of different regressions for data. So after watching this video you should be able to define residuals and then use a residual plot to assess the reasonableness of the type or the shape of the regression used to model some data. Right, big things to recall, so we're always using scatter plots. So make sure you know how to create and use a scatter plot, and also talk about our lines of best fit. But it won't just be lines we consider, we might also consider some curves of best fit too. All right, so what are residual plots and what do we use them for? So residual plots are used to identify problems with regressions. So they basically help us work out, is the regression that we've chosen to use, whether it's a linear or some sort of curve, is it reasonable? And if it's not, what could we try or what could we do to try and improve our model? Now, this just opens up another question mark. What is a residual? So residuals are the vertical distances between a data point and the regression or the prediction that our line or our curve of best fit provides. So in this case, let's look at a couple of data points here. Let's look at this one here. Right, that's our 4.2. And let's look at this one here. The next one along, that's our 5.8. So this 4.21, our residual is this vertical distance between our data point and the prediction according to our line of best fit. So our data point has a value of 6.8. According to our prediction line, that's about 7.7. I don't know, I'd guess. So this distance, this residual distance, will just be the 6.8 subtract 7.7 to get negative 0.9. Now, key thing with this residual, it is negative because it's going below our line of best fit. Our data point here is below our line of best fit. It's below our regression, so that's why we've got a negative value here. The value up here at 5.8, sorry, it's got a height of 7.2 according to our data. Reading off the graph, that looks like it's about 6.5. So if we subtract 6.5 from 7.2, we get 0.7 is our residual here. And that answer is positive because our data point is now above our line of best fit. Okay, if you're looking for formulas, the residual is calculated by subtracting the predicted value. So that's these values we had here. These were our predicted values according to our line of best fit. Subtracting those from the actual value of the response variable, which were in this column here. So subtracting those values gives us our residuals, and then we can use those to create our residual plot. All right, so a residual plot then basically displays the explanatory variable on the x-axis, the same as our normal scatter plot, but instead of plotting our response variables or our y values, we don't plot those on a residual plot, we plot all of these residuals that we've got calculated here. And they're above and below this line 0. So 0, in this case, means that our predicted value and the actual value are exactly right. So something like this point here, up at 6.4, but this residual is very low, it's very close to 0. So that means the predicted value, according to our line of best fit, is basically the same as the actual data. These ones that are a bit further away here, so 4.2 and 5.8, the values we looked into, those ones are where the data varies the most from our line of best fit. All right, so then how do we use this? How do we use this to evaluate the effectiveness of the models that we've chosen? So a residual plot can indicate that an incorrect regression has been used. Right? So it doesn't really tell us if a regression is excellent or not so good. It basically gives us reasons to say it's not good. So a residual plot can indicate an incorrect regression if the data points are not evenly and randomly spread. Okay, so if there's, let's say there's 8 data points above and 2 below, that would not be a good model. Okay, because that just shows that there's the data is not spread out, it's not random. Secondly, if the residual plot indicates that an incorrect regression has been used if there is an association. So if you look at your scatter plot and there seems to be some sort of association, that means that there's some sort of variable, or there's something that hasn't been considered when creating your line or your curve of best fit. So basically the keywords you're looking for, or the key things you're looking for in a residual plot, are evenly spread either side of the x-axis. So you want some positive residuals, some negative residuals, and you want them to be randomly placed. If those things are true, your regression is probably good. If those things aren't true, then you need to try some sort of different regression instead. All right, so let's do some examples. So for the residual plot below, justify whether or not the regression used was reasonable. So we're justifying here. So we can't just say yes or no. We need to give a reason why. So looking at our data sets here, I'm going to say it's not reasonable. Right? It's not reasonable. We've got 4 data points below, and those ones are all between -1 and 0. Up on this side, we've got 5 data points. We've only got 2 that are between 1 and 0. We've got 3 data points that are greater than 1. So this regression is not reasonable. That was used to try and model this data because the data points are not randomly distributed. They're not evenly distributed either. So there are more points above the x-axis, and generally they're further away. So they're greater than 1. Right? They're further away from 0 than the negative residuals, and there's more of them, more positive residuals. So not a good model, not evenly spread and not random. All right, the second one, looking at these data points, they're all random, they're all up and down. There's no discernible pattern, they're evenly spread. Right, we've got 4 above, about 4 below, and this 1 on the line. It looks pretty good. It is a reasonable regression. The data points are evenly spread, and they're randomly distributed at either side of the axis. All right, finally, what about this one? This one, no, it is not reasonable. These data points are not randomly distributed. Look at this. There's a nice, neat curve that can be drawn. Okay, that goes through all of those data points. So it's not random. They're not dots all over the place like in that previous example. There looks like there's some other sort of association because the residuals are following a nice, neat pattern. Right. Now, if you wanted to, right, these residuals form a parabolic shape. If you know what a parabolic shape is, that's the curved, arch-looking sort of shape there. So that means in your regression, it's probably worth trying to find a parabolic regression. So the shape of the residual plot gives away a bit of a tip or a bit of a hint for what kind of regression could be used instead. All right, so students, after watching this video, you should be able to define residuals and also use a residual plot to assess the reasonableness of a regression that has been used to model data.